Hello, third grade Eagles. So today what we are going to be talking about is how to represent a fraction to make a whole number, or how we can show whole numbers to show fractions. So if I were to look at this whole, right, and my whole might be broken into two parts. I know that each one of these parts is worth 1/2, or 1 out of 2 parts. And I know that in order to represent my whole number, if I were to shade these in, I know that my shaded portion would be 2 out of 2 parts, or 1 whole. Just like if I were to have another whole of the same size, and that whole was broken into 4 parts. And we know each one of those parts is worth 1/4. And I have 4 1/4 pieces. Or if I were to shade that in and shade the whole thing in, I know that that would be 4/4, which is equal to 1 whole. That's all things that we've kind of gotten used to, and that's a review. But what would you do if I said that I now have 3 holes, and each of these holes were broken into half pieces? So I know I have 1/2 and another half. I know I have 1/2 and another 1/2. And I know I have 1/2 and another 1/2. And then Miss Wackus all of a sudden was to go ahead and shade all of these pieces. Well, first of all, I might look and say, well, I know I have 1/2, 2 halves. I have 1/2, 2 halves. And I have another 1/2 and 2 halves, which if I were to put all of those together, I could say I have 1, 2, 3, 4, 5, 6 halves. But I also have what? How many holes do I notice here? I notice 1 hole, 2 holes, 3 holes. So having 6 halves is the same as saying I have 3 holes. Interesting. Let's look at another example of that. If Miss Wackus all of a sudden had 2 whole boxes, and those 2 whole boxes were split into thirds, that means there were 3 parts to make a whole. And I know that this part represents 1/3, this part represents 1/3, this part represents 1/3, and it continues, right? We have 1/3, 1/3, and 1/3. And I were to go ahead and shade in all of these boxes, I can pretty easily count and say I have, get my color, 3/3 and another 3/3. And if I were to count, I could say I have 1, 2, 3, 4, 5, 6/3, or that is equal to 1 whole, 2 holes. And again, that might be a little familiar because we talked about that when we were looking at number lines. All it is counting up those little parts and figuring out how many holes that is. But guys, there's another way to do this. And guess what? It kind of includes parts, but it kind of doesn't. What if all of a sudden, just like that last picture, I said I had 3 holes, but I don't see any parts? Well, I could say that this is one part out of one part that makes a hole. This is one part out of one part that makes a hole. And this is one part out of one part that makes a hole. And if I were to count that, I could say I have 1, 2, 3 holes, and 1 part makes a hole. So I have 3 out of 1, or 3/1 ones, and that would be 1, 2, 3 holes. Or Miss Wackus could have, and call me crazy, 5 holes. And again, each of these I can look at as one piece out of one to make a whole. And if I were to continue to count those, I could say I have 1, 2, 3, 4, 5. And it only takes one piece to make my whole, so therefore I have 5 holes. And that's really all you're going to be doing in your work today, is counting out how many pieces and looking at that denominator to make sure that denominator stays the same, and counting how many pieces on the numerator do you have to make the whole, and how many holes do you have. Make sure that on your Draw It, you go ahead and you work through every problem and you click submit, and Ms. Wackus will be looking at it and giving you some support. I hope this makes sense. If you have any questions, feel free to reach out.